Okay, so now we're going to talk about non-uniform loads, and this is a load where the intensity varies along the length. If you'll look here at this picture, here the load is at its maximum intensity, and here it's down to 0. Alright, so the magnitude of the resultant of this is similar to the formula for area of a triangle. It's 1/2 little w times L. Okay, so it's 1/2 whatever W is here, okay, the maximum load intensity, times the length of the load. Alright, now where is it going to be located? The resultant is going to be located 1/3 of the way from the fat end of the triangle, or the maximum load intensity. Okay, so if this is 0, okay, and this is 9, let's work out this question. If the load intensity were 100 pounds per foot and L was 9 feet, what is R and where is it located? Okay, so the load is going to be equal to 1/2 times the 100 pounds per foot times 9 feet. Okay, so that load is going to be equal to 450 pounds. Okay, what's the location? Alright, it's going to be L divided by 3, which is going to be 9 divided by 3. And so that's going to be at 3 feet. So it would be right here. Okay, 3 feet. Alright, so let's look at this example problem. Okay, we have a distributed load of 25 newtons per meter. It's non-uniform, and a 50 newton if I want to know the resultant and the location of this system. Okay, I have to begin first by turning this non-uniform load into a single force. Alright, so let's do that first. Okay, is going to be equal to 1/2 times 25 newtons per meter times 4.5 meters. Okay, and that is going to be, when I do it in my calculator, I get 56.25 newtons. Okay, where's that going to be located? It's going to be at the length divided by 3, which is equal to 4.5 divided by 3, which is going to be 1.5 meters, I think. And it's going to be 1.5 meters from the maximum load. Okay, so that turns into this system. Alright, and this one is at 1.5 meters. And this one is at 5.5 meters. Alright, because I take the 4.5 plus the 1, okay, and so this is the 50 Newton force, and this is the 56.25 Newton force. Alright, so in case you don't remember, then we're going to use the formula R equals, and just add them up. It'll be negative 56.25 newtons plus a negative, so that's the same as minus 50 newtons. So R is going to be equal to negative 106.25 newtons. Okay. Now where's that going to be located? That's where we do X bar. So X bar is going to be equal to the sum of the moments divided by R. Okay, so X bar is going to be equal to, alright, we've got 56.25 newtons times 1.5 meters. Okay, that is going to tend to cause, if we look here, okay, that's going to tend to cause a clockwise rotation. We said that was a negative moment. Plus, okay, the next one's also going to be a negative moment. Imagine we're holding it down at A, we put our finger on it and we're pushing down here, that's going to be clockwise again. So that is 50 newtons times 5.5 meters. Alright, and all of that is going to be divided by, oops, I left my negative sign off. It's going to be divided by a negative 106.25 newtons. Okay. Alright, so let's plug that into our calculators and see what we get. So I got 359.375. Oops. Let me write X bar equals Newton meters divided by, and that's a negative number, divided by a negative 106.25 newtons and I get 3.38 meters. Okay, so that's a non-uniform load. And so that concludes the section on non-uniform loads.